Now we're in section 7.5, which is the last section in the chapter. And 7.5 is all about solving. So you're going to have all sorts of equations with equal signs. We're going to look at how we solve things that are exponential, and we're going to look at how we solve things that are logs. Rather than make one or two really long videos, I decided I was going to break it up into a series of short videos to explain the problems that you'll have to do right after each video. I think that'll make it easier to kind of break down for you. So here's our first type. So our first type of solving is when we are going to have exponential equations on both sides, meaning both sides have a base and an exponent. And our goal is to get the bases to be the same. So the first example is a really good example of how this is really easy. If your two bases are the same, so if you look at this one, these are both base 7 exponentials, then that means the exponents must be equal. So we can ignore the 7s and say, well, if they're both base 7, then 2x plus 5 must equal 15. So setting the exponents equal to each other once the bases are the same. And then you're left with something really easy to solve. 2x equals 10, so x equals 5. So that's your absolute easiest. Most of your problems and looking at what they ask you to do on Delta Math, the bases won't be the same to start. So your job is to get them to be the same base. You want to work with small numbers. Get them all to be base 2 or base 3 or base 4. So for example, on this next one, you can get both of them to be base 2 because 2 squared is 4 and 2 cubed is 8. So we can get them both to be base 2. So what we do is we write 4 as 2 squared, but it's still to the 3x. And we're going to write 8 as 2 to the third, but it's still to the x plus 1. Now, my bases essentially cancel, but I have to multiply my exponents together. I'm basically using exponent rules here. So on the left side, I have the 2 times 2x, 2 times 3x, excuse me, is 6x. And on the right side, I have to distribute 3 times x and then 3 times 1. The bases cancel, and you're just multiplying or distributing your exponents together. So then I subtract 3x. So I get 3x equals 3, and then divide both sides by 3 to get 1. And you can check any answer in this entire topic today by just taking that x value and plugging it back into the original equation. The next one came straight from Delta Math. You can kind of tell by the font. I can get both 27 and 3 to be base 3 because 27 is 3 cubed and 3 to the first is 3. So both of them I can get to be in base 3. So I'm going to write this as 3 cubed, but it's still to the x plus 4. And I'm going to keep this as it is. I don't need to change it. It's already in base 3. So now my bases cancel since they're alike. I have to distribute the 3 here, so I get 3x plus 12. The number one mistake students make is forgetting to distribute. Equals 2x plus 5. Subtract 2x. So I get x plus 12 equals 5. Subtract 12. And I get x to be negative 7. And you can get negative answers here, and you can check your work by plugging that answer back into the original. So let me show you just a couple more. So this next one, we have a base 3 and a base 9. We can get both of those to be written as base 3. So the 3 is not going to change. But 9 can be written as 3 squared to the x minus 3. My bases are the same. Some people call it equating bases, getting the bases to be the same, so they cancel. So on the left side, I get 3x plus 5. And on the right side, I have to distribute the 2, so I get 2x minus 6. Subtract 2x, so I get x plus 5 equals negative 6. Subtract 5, I get x to be negative 11. This last one also came from Delta Math. You can kind of tell with the font. This one, I think you can get them both to be in base 2, but I think you also could go in base 4, and you might even be able to go in base 16. And the nice thing is any of those work. I think 4 would work, though. What is 4 to the 4th? 256. Awesome. So again, if 4 doesn't work, you could do 2. A lot of these have options. So I'm going to write this as 4 to the 4th to the negative 1. And then 16 is 4 to the 2nd to the 2x minus 2. So they're both base 4, so I'm going to cross off the base. On the left side of the equal sign, 4 times negative 1 is negative 4. On the right side of the equal sign, I have to distribute this 2. I get 4x minus 4. So I'm going to add 4 to both sides. So I get 0 equals 4x. That's interesting. I'm not used to getting 0 as an answer. Divide both sides by 4. and we get 0. I'm glad I did this one because usually when people get 0, they think they did something wrong. And again, you could put 0 back in here and you could check to make sure that both sides are equal. So that's your first type of solving. When you have exponential pieces on both sides, the goal is to get both to be the same base. Again, think small, think base 2, base 3, base 4, and then set your exponents equal to each other.